In example 4.2, which is on page 187, we are asked that suppose a spin half particle is in the state and chi is given as this. What are the probabilities of getting this eigenvalue and this eigenvalue, which is half h bar and minus half h bar, if we measure Sx, Sz and Sx on this system, right? So we will have to find those probabilities. Now I can write the very first one for Sz. Here first I will write this state into the state which I have already done. So the state which was A chi plus B chi minus, this was the state. And now the state is written like this. So I will have to see that what are the values of A and B. I can write this state in terms of this one, chi equals, if I write this is 1 plus I by 6 and 1 0 plus 2 over 6 and 0 1, right? Then this is actually A, this is chi plus, this is B, and this is chi minus. So I have written the state which was given in terms of A and B here. So I know now that what is A, what is B. So the values of A and B are known. Now I will just apply the calculation. So A here is 1 plus I by 6 square root, and B is 2 over 6 square root. Now I will have to check that this was the state which we have written for Sc, if you remember. This general state was for Sz, while a while ago we solved for C and D here, and this was chi plus x and chi plus x, chi minus x. So those were the states for Sx, while the state for Sz is straightforward. For Sc, A is the probability, means a small square is the probability of the state 1 0, which is spin up state, while this is spin down state. So as you have determined this one, now the probabilities are easy to determine. A mod square will give you the probability of getting plus half h bar over 2. So A mod square will be what? You will take, means A conjugate into A. So A conjugate will be what? A 1 minus I by square root 6. It will be the conjugate, A conjugate. This is multiplied with 1 plus I, the A itself. So these two are multiplied. And what this will give? A square minus B square. So 1 minus minus 1. It becomes 2. And this one, 6 and 6 square roots, it will give you 6 here. So this is equal to 1 over 3. So the probability of getting plus h bar over 2 when you measure is z on this system is 1 over 3. The other one will be automatically 2 by 3 because there is no other value, but we can calculate that b square is equal to b conjugate into b, while the conjugate will have no effect on this one, and it will become 2 over 6 multiplied with 2 over 6, and this will be equal to 4 over 6, and this is 2 over 3 for minus h bar over 2. And you know 1 over 3 plus 2 over 3 is 1, because 3 divided by 3 is 1. So this is for SZ. And now when we measure for SX, then for SX you know that the generalized state was what? It was chi C chi plus x d chi minus x. This was the state. Just remind yourself about the Sx and Sy. They are like Lx in Ly. They are the raising and lowering operator, L plus and minus. They are playing the role. While Lz there was on the generalized state. And similarly here Sc is on this state. While when it will be Sx, then x will come here. When it will be Sy, y will come here. Clear? These are on the plane. Okay, these are on the plane of Sx and Sy. So we will have now to calculate this one. You remember the values of C and D here. This was equal to A plus B by 2 chi plus x. What? Square root? It's okay. Plus A minus B over 2 chi minus x. So the probability will be, here it's a square root. So we have the probability of getting plus h bar over 2 is with chi plus x. So the probability will be A plus B mod square over 2. And you know that it will be A plus B conjugate into A plus B whole by 2. Now, what is A here and what is B here? Look here. This square root 6 is common between the two. Clear? So it will be A plus B. So write this one. What is A? A is 1 plus I. 1 plus I. And plus 2, because it is here 2. And this is with conjugate. And we are having 2 here. Let me write it first. Then 1 plus I plus 2 plain, not conjugate. What? This 2 is coming in from here. But here is 1 square root 6 and here is 1 square root 6. When they multiply, we will get 6. So 2 multiplied by 6. You can solve this one. When you take conjugate of this one, what it will be? 1 minus I plus 2, and this will be I plus 3. So this is 3 minus I by 12. This is 3 minus I, and this is 3 plus I by 12. A square minus B square. So what it will be? 3 square, 9 minus and minus 1 plus 1. So 9 plus 1, 10 by 12. And this is 5 by 6. So 5 by 6 is the probability of getting plus h bar over 2. Now you don't need to calculate the minus h bar by 2 probability, because we know it will be 1 by 6. But even if you want to calculate, you can do that minus h bar over 2, it will be a minus mod square by 2. And this, when you do calculate like this, you will get this 1 over 6. Clear? And this will give you the total probability is equal to 1. Clear? So you are having this state. Let me repeat. This is a generalized state. I wrote it as the generalized state on which I can directly apply SZ. The SZ generalized state is A chi plus B chi minus. And here the probability will be A mod square and B mod square. A mod square for the plus h by 2, h bar by 2, and this one minus h bar by 2 probability will be B mod square. And then I move to the eigenstate, generalized eigenstate for Sx. Then this generalized state, I will have to write in this form. And in terms of the generalized state for Sz, it will be like this: A plus B by 2 square root. Now this is the generalized state on which I can directly apply the probability calculation. So the mod square of this and the mod square of this will be a plus half h bar probability and minus half h bar probability. And I did calculate this thing, and it is 5 by 6 and 1 by 6. Clear? I will not fully solve another example, but will give you some hint how to do this thing. This is your problem 4.30. Problem 4.30, and this problem is 4.30 in this is 4.27 in your second edition, the one that we are following. While the same problem is now 4.30, there is no change in the content of the problem, only the shuffling of numbers. This is in the third edition. The third edition is really computer friendly, it is clickable, and it is really, it is like an electronic version, the third edition. So this problem states that an electron is in the spin state, an electron is in the spin state, and the spin state is that chi is equal to A 3I 4. So the very first question it is asking is determine the normalization constant. Determine the normalization constant. Normalization constant, which is A. Can you determine the normalization constant? It's very easy. Just do chi conjugate in chi equals 1. So what it will become? When you take the conjugate of this one, A will become a conjugate. This row matrix, column matrix will convert into row matrix transpose, and 3I will become minus 3I. Right? You will multiply with this one and this one, and you will get the normalization constant A equals 1 over 5. It's very easy. Even you can do like this. 3, it will become 9. 4 becomes 16. 9 plus 16, 25, goes there, takes square root 1 over 5. So it is very easy to find the normalization constant. Part B. Part B is saying find the expectation value of Sx, Sy in Sc. Means the expectation value of Sx, Sy and Sz. Can you find these expectation values? The expectation value is you did in the case of integration for functions. Here we are not having functions. Here the observables are in the form of matrices. So Sx will be chi conjugate Sx and then chi. This will be a calculation way to do this thing. And you know the value of Sx. Sx is half h bar 0110, right? So put the value of Sx. Put this value, chi conjugate. Chi conjugate will become A conjugate, so it is 1 by 5, so it is will remain 1 by 5. This will become minus 3I and 4 in a row. And then you will put for Sx its value, the matrix form, and then here you will put the row form here. So in the column form, as it is. And you will do multiply this. And when you do multiply, you will get minus 12 by 25, and this is h bar. Similarly, you can calculate Sy and Sc in this. These are very solid questions. You can calculate them very easily. While the third part C is asking for the uncertainties. The uncertainties associated sigma Sx and then sigma Sy and sigma Sz. You know how to calculate them. You know that sigma Sx squared will be, if you calculate the expectation value of Sx squared, and you subtract the Sx value square, the expectation value square. This is the S squared expectation value, and this is the Sx expectation value square. Two are different to calculate this one. So you have calculated this one already. Take direct square of this one, and then calculate Sx square expectation value square. So put square here, and you can calculate this one. Similarly, you can calculate the next and the next. And then part D is asking to verify the Heisenberg uncertainty principle. To understand the Heisenberg uncertainty principle, I have explained it in a couple of videos. In quantum mechanics, last week I have done this thing, and then I have explained this in much detail, that what this uncertainty means. What it means, the commutation relation, that x and p you cannot measure simultaneously with an accuracy. So I have explained this in the conceptual physics series. You can go to those videos. But here we will have to calculate that what if we find the two uncertainties like sigma Sx and sigma Sy. These are non-commuting operators, you know. And two non-commuting operators, when you multiply their uncertainties, then this will be greater or equal to h bar over 2. So check that your result of the one that you have found here is coming out to be greater or equal than this. If it is coming out less than this way, then it means you have done something wrong here. Clear? So this is one of the relevant problem. You can do practice on it. 4.28 is also a relevant problem. Do practice on that one as well.